So the next question, a game involving chance is said to be fair if the expected amount won or lost is 0. Consider the following game. A player pays $1 and chooses a number from 1 to 10. A spinning wheel then randomly selects a number from 1 to 10. If the two numbers match, then the player wins $5. Otherwise, the player loses $1 entry fee. Let the random variable W denote the amount won by the player and draw its probability distribution. So here actually it should be net amount won, not just amount won. If it is amount won, then it should be 5 and 0. But if we look at net amount won, then it shall be 5 or -1 with probabilities 1/10 and 9/10. Why is it 1/10? Because the spinning randomly selects a number between the spinning wheel randomly selects a number between 1 and 10, and if that number is equal to the number that you have chosen, then it becomes 1/10. So it's 1/10 and 9/10. So the important thing in this question is the net amount won, not just the mere amount won. So the next question, in a common type of lottery, the customer buys a ticket with a 3-digit number from 000 to 999. A machine such as one with bouncing balls numbered 0 to 9 then selects a number in this range at random. Since each ticket bought by a customer costs $1, whether the customer wins or loses, customers with the winning tickets are paid $500 for each winning ticket. What is the distribution of X when X denotes the net amount won? Once again, using previous argument, if we don't win anything, then we lose that $1 which we had spent to buy the ticket, so it is -1. And if we win that $500, then the net amount won is 500 minus 1, so it is 499, and the corresponding probabilities are 999 by 1000 for losing, and it is 1/1000 for winning. Is that game fair? Yes. In order to find whether the game is fair, we have to find the expected value. If the expected value is here, the expected value is -1 times 999 by 1000, 499 times 1000. When we add these two, we get -500 by 1000. So the game would be fair if the expected value of X is 0. So we can say that the game is not fair. So a game requires the player's probability of winning must be equal to the player's share of the pot of the money awarded to the winner. All money is put in the pot at the start of the game, and the winner claims the entire amount. The player and the host each puts $20 into the pot. The player rolls a die and wins the pot if the winner produces an even number. Is this game fair to the player? Well, X is the amount won by the player, and here we say that the player and the host each puts $20 in the pot, and the player rolls a die and wins the pot if the die produces an even number. So the player loses $20 if an odd number appears, which is 1/2, and the player wins $20 if the even number appears, that is 1/2. And as you can see, the expected value is 0, so the game is fair. A player at a casino puts $1 in the pot and names a card from a standard deck. The casino puts $99 in the pot. If the randomly selected card matches the choice of the player wins the pot. Is the game fair to the player? Let X is the amount won by the player. Here the player loses -1 with probability 51 over 52, and the player wins $99, which is the amount the casino had put in the pot, with probability 1 over 52. Here the expected value is not 0, so the game is not fair. So now the next question is, two companies compete to define a new standard for digital recording. Only one standard will be adopted commercially. Company A invests $10 million to promote its standard. Company B invests $20 million to produce its standard. If the outcome is to be viewed as a fair game, what is the chance that the market accepts the proposal of company A? So here the random variable x denotes the company A's profit in million. P is the probability that the company A's proposal is accepted. The random variable takes the values 20 and 10, negative 10, with probability P and 1 minus P. Why is it 20? Because if A wins, then A wins over. If A's proposal is accepted, then A wins over company B's investments, which was 20 millions. But however, if A's proposal is not accepted, then A loses whatever it had invested, that's why we have a negative 10 here. So now what is the expected value of x? It is 20 times P minus 10 times 1 minus P. Now in order for this game to be fair, the expected value of x must be equal to 0, which means this expression must be equal to 0. Now on simplifying, we get P equals to 1/3. So the probability that the company A's proposal is accepted is 1/3. So now in this question, an investor buys these stocks of companies investing 1,000 in each, 10,000 in each. The stock of each company either goes up by 80% after a month, which becomes 18,000 with probability 1/2, or drops by 60%, falling to 4,000 with probability 1/2. Assume that the changes are independent. Let the random variable x denote the value of the amount invested after 1 month. Find the probability distribution of x. Find the mean of x. Now here in this question, my random variable. You don't have to work this out the way I have done, but I will share with you what I have done, and I will tell you what you could have done otherwise. So my random variable of interest is the value of the amount invested after 1 month. So when I say value of the amount, it is the 10,000 plus the 10,000, which is the 20,000. Now notice this random variable can be written as sum of two random variables. So this random variable can be written as sum of two random variables, x1, which is this, and x2, which is this. x1 is the return from stock 1 and x2 is the return from stock 2. So x1 is the return from the first 10,000 and x2 is the return from the second 10,000. So the first 10,000 becomes 18,000 or 4,000 with probabilities 1/2 and 1/2, and the second 10,000 also becomes 18,000 or 4,000 with probabilities 1/2 and 1/2. So my random variable could take either the value 36,000. So now let's look here. The random variable can take, so my random variable x, which is the final, which is the value of the 20,000 invested after 1 month, could either become 36,000 when both the first investment becomes 18,000 and the second investment becomes 18,000. And if these events are independent, and because these two events are independent, that is the first investment and the second investment, this probability is the product of the two probabilities, which is equal to 1/2 times 1/2, which is 1/4. Then my value could become 22,000 if the first investment became 18,000 and the second investment became 4,000, or the first investment became 4,000, that is we lost, and the second investment became 18,000. Now because these two events, that the first 18 and second 4, or second 4 first 4 and second 18, these two events are mutually exclusive. Therefore, the probability of their union is the sum of these two individual probabilities. Now, because the random variables x1 and x2 do not, the values of the random variables x1 and x2 do not depend on each other, therefore probability of x1 equal to 18 comma x2 equal to 4, which is x1 equal to 18 and x2 equal to 4, is equal to x1 equal to 18 times probability of x2 equal to 4, because the random variables x1 and x2 are, because the events x1 equal to 18 and x2 equal to 4 are independent of one another. Likewise, we have for the second thing here. So what do we have? 1/2 times 1/2 plus 1/2 times 1/2, which is 1/4 plus 1/4, which is equal to 1/2. What about probability of x equal to 8? That happens when x1 equal to 4 and x2 equal to 4. Once again, because these two are independent, so we have x1 equal to 4 times x equal to 4, which is 1/2 times 1/2, which is 1/4. So the distribution of the random variable x takes the values 1/4, 1/2, 1/4. 39. A construction firm bids on a contract. It anticipates a profit of 50,000 if it gets the contract for the full project, and it estimates its profit to be 20,000 on a shared project. If the firm estimates that there will be a 20% chance it will get the full contract, that there is a 20% chance that will get a full contract and 75% chance that will get a shared contract, and otherwise it gets nothing. Now this part of the statement is very important. Otherwise it gets nothing. And also notice this 20 plus 75 is not 100. That means there is a 5% chance of getting nothing. So what is the random variable here? It is the bid of the outcome of the bid of the firm, and we have to find the distribution of the random variable. So the random variable is the amount for the bid of the firm. So that takes the value 0, 50 or 20. 50 with 20%, it was given here. 20 with 75%, that is also given here, and otherwise it gets nothing. So it gets 0 with 5%, that's also given here. What is the expected value? What is the expected value of this random variable? Well, straightforward calculation of the expected value, that gives you 25k. What about the standard deviation? The standard deviation is the square root of variance. So first we have to find the variance. How do we find the variance? We find expected value of x square, which is 800, and so that we have the first part. What about expected value of x? We knew that was 25. Square of that is 625. So variance of x is 800 minus 625, which is 175. So the square root of the variance is square root of 175, which is 13.2, and that is our standard deviation. Now the next question. The manager in an office. So the manager of an office has estimated how many reams, packages of 500 sheets, are used on a daily basis, and has assigned these probabilities. The question is, how many reams should the manager expect to use each day? So when we see here, the important word is expect, which means we have to calculate an expectation. Expectation of what? Expectation of a random variable. What is the random variable? The random variable is the number of reams of paper used. And what is the value of the random variable? 0, 1, 2, 3, 4 or 5. Now probability of the corresponding probabilities is 0.05, 0.25, 0.35, 0.15, 0.15 and 0.05. So how do I find the expectation? The straightforward use of the formula for expectation, which gives me 2.25. Next is, what is the standard deviation? Once again, a straightforward use of the formula for standard deviation, which is the square root of the variance. How do I find the variance? The variance is expected value of x square minus expected value of x whole square. The expected value of x square is 6.65, which I get from 0 square times the corresponding probability, 1 square times the corresponding probability, 2 square times the corresponding probability, so on and so forth. That gives me 6.65. Square root, the standard deviation is the square root of the variance, which is square root of 1.5785. So how did I get the variance of 1.5785? Sorry, 1.5875. I took the expected value. So the variance, as you remember, is what? The expected value of x square minus expected value of x whole square. What is expected value of x square? That is 6.65. What is expected value of x whole square? It is 2.25 square. So we have 6.65 minus 2.25 square, which gives me 1.5875. The standard deviation is the square root of that, which is 1.260. The next thing is find the standard deviation of the number of reams used at the end of the day. Sorry, part C. If the storeroom has 20 reams at the start of the day, how many should the manager expect to find at the end of the day? Here the random variable is how many should the managers, what we want to do is to find the expectation of the number of reams at the end of the day. How do I do that? Well, the random variable here is y, which is the number of reams at the end of the day, and y is equal to 20 minus x. Now here this y can be written as ax plus b, where a is -1 and b is 20. b is 20. So what do? I have my expected value of y. The expected value of y is the expected value of 20 minus x, which is equal to what? Now, so here we use the formula expected value of ax plus b is a times expected value of x plus b in a very crucial way. So my a was -1, my a was -1, and my b was 20. So this shall be equal to negative expected value of x plus 20, and that is why we have 20 minus 2.25, which is 17.75. So the variance of y is equal to 20 minus x, which is -1 square variance of x. Standard deviation of y is the square root of the variance of y, which is square root of the variance of x, which is the standard deviation of x, which is 1.26, which was our initial standard deviation. So now the next part of the question is find the standard deviation of the number of reams found at the end of the day. Found at the end of the day. So we are essentially asked to find the standard deviation of this random variable. Okay, so that's what we did. We found the expected value. We found the expected value and the standard deviation. So that is also done. So now then is find the mean and the standard deviation of the number of pages used each day, assuming that each ream is completely used. So the number of pages used. So x was the number of reams used. So the number of pages used is 500 times x. So we have to find the expected value and the standard deviation of this random variable w. So the expected value of w is expected value of 500 times x, which is 500 times expected value of x. How did I get this? Same way as above. So w is equal to ax plus b. My a is 500, my b is 0. So the expected value of w should be a times expected value of x plus b. Now since b is 0, so we are just left with a times expected value of x, and that's what we have. So this is the formula which is being used with a as 500 and b as 0. What about standard deviation of w? Well, here we use so this is the square root of the variance of w. Here we use the formula variance of ax plus b is a square variance of x. So we have variance of 500x is 5 square variance of x. Square root of that is 500 times standard deviation of x, and so we have 500 times 1.26, which gives me 630.